Hi, my name's Mark. I'm going to walk you through today some of the different Excel functions that are necessary for understanding how machine learning algorithms like neural networks work. And I'm going to use Excel to do that. But in order to understand where I'm going to, I want to talk about some of the basic functions that are within Excel so that you understand when you see them later. So I'm going to go ahead and pull up. Okay, this video is going to go into one of the tabs that talks about a few different concepts or functions within Excel. One is variables within Excel, and another is matrix multiplication and how that works. And this is all from the Excel file that I created, which is titled A Few Good Things to Know About Excel. So without further ado, I'll pull up the Excel file. And you can see here we're in this second tab that's called Variables and MMULT, or Matrix Multiplication. We're going to start with the top formula. Okay, so we have a formula here, y is equal to theta naught plus theta 1 times x1 plus theta 2 times x2. So now a few things to understand. X's are inputs. So whenever you see x1, that is one input. Whenever you see x2, that is a second input. So these can be different features or signals that are entering into your algorithm. Theta naught, theta 1, and theta 2, these are your model parameters. So these would be parameters that are set in order for your model or your algorithm to work. And then y is going to be that model prediction. So this is a really simple case, again, with just two different inputs, and you're going to predict one output. So the easiest way to do this is, here's y. You can do equals, and you can select the different variables. So theta naught plus theta 1, you want to multiply that by x1 plus theta 2, multiply that by x2, and then you can hit enter, and there we go. You know, it's going to make prediction. And I just chose x1 and x2 as random numbers, so you see them change from time to time. Now here's what this looks like with variables. You know, as you step through the next one, it makes things simpler, and we'll see that later, how you would implement this formula with variables. So you can click on this first one, the value for theta naught. You can go up in the corner here, and I kind of showed this in this box off to the side, but you can click on that and enter theta naught. You can go to theta 1 and click theta 1. And the interesting part is these are going to name these as variables, and then you can use them in the formula later. You know, so here if we did theta naught, it knows what that is, and it actually selects the right cell. You know, but we're not just going to do that. Another way to do it, if you have a whole bunch of different variables, is you can select the whole thing, go up to the top to the Formulas tab, and we can do Create from Selection. So create from selection, we want the names for the values in the top row. And so we click OK. And this is actually, let's see if it works, equals x1. Yeah, see, it's actually linking to x1 now. So it knows what these variables are. So now we can start to use these within our formula. So we can do equals theta naught plus theta 1 times x1 plus theta 2 times x2. And you can see that this matches up with what we had earlier. Again, we set x1 and x2 to carry down, so it's the exact same values. So you can see that it's actually making a prediction of the same thing. It's just now it is only using these variables. What is interesting is if I redid this as theta 1 plus, or theta naught plus theta 1 times theta 2, you can see that it's actually replacing it with the variable names. It's like I know what these variable names are. And so there we go, and we're getting the same value. But again, it actually, when you reference the cell, it will actually return the variable name so that you can see that within the formula. Okay, the nice thing about variables as well is you can copy that formula and paste it anywhere else. And you see it still follows these cells, so they didn't actually shift like they would with a normal formula. I'm going to delete that. Now we're going to go down to formula using matrix multiply. So you see the formula here. It looks very different than actually this formula up above, but it's actually the same. You know, what happens when you're multiplying matrices is right here you have x naught times theta naught plus theta 1 times x1 plus theta 2 times x2. Or shorthand, just x multiplied by theta. So now what we can do here is, instead of just naming each cell with a variable name, you can actually select all of these and go up and name it theta. And we can select all of these x's and go up here, and we want to give it x underscore as the name. And now we're going to do matrix multiplication. So we're going to do equals MMULT of x underscore comma theta. And you see actually it's a different color for the variables within the formula, just to show that it recognizes what those are. You can also see that the color, like of theta is red, for instance, matches up with the cells that is selected with this red box. So you can now hit enter, and look, we got the same prediction once again, but the formula is much simpler. You know, you can see that it's going to reference multiple different cells and do a matrix multiplication. The reason that this works, that it looks a little bit different than this formula, theta naught, if we set x naught to 1, then 1 times theta naught is theta naught. So often you'll actually put 1 for x naught just to make the matrix multiplication easier. And it kind of outlines that in the file too if you wanted to try that. And what's really great is this makes it so easy that you know, we now have that variable theta stored from up above. You know, we've added a 1 here. We've selected a whole bunch of new random numbers. And the way that you can think about this is each of these rows is going to be a different trial run or experiment where we have different inputs for it. And we want to make a prediction for each of these different experiments. Now in real life, we'd have, you know, a ground truth value for that prediction that we can compare against and see our prediction. You know, so now we're gonna, it looks like, name this whole thing x big. So we can select this whole thing and we'll just name this x big. So now we have this new variable there. And this is called a dynamic array, something that I will talk about in future. Now we can do equals matrix multiply. We're going to do x big, and you can see it selected all of those, comma theta. So this is this x times theta matrix multiplication. When we press enter, look at that. It made predictions for all of these different trial runs or experiments or observations that you have. For each column, this is what that prediction would be. And so, again, as we explore neural networks and how they operate. Matrix multiplication comes into play quite a bit. It's very handy. Computers can do this extremely fast, which is why it's used so often within these neural network algorithms. So with that, hopefully I've covered variables, matrix multiplication, and in the next videos we'll move on to some of these other tabs.